Okay, today we are going to take a look at another application of Pascal's triangle, and it has to do with what we call binomial expansion. So if you recall, a binomial is just something that has two terms, added or subtracted. And so if we think about like raising a binomial to a power, so for example, if I raised a plus b to the 0, right? Well, anything to the 0 power is 1. And then if I raised a plus b to the first power, then that would be a to the first plus b to the first, right? And I'm going to go ahead and put 1s in front of those just for fun. So I'd have 1a plus 1b. And then if I square it, then I would have 1a squared plus 2ab plus 1b squared. Right, because off to the side here, if I wanted to, I could multiply that out, right? A plus b times a plus b. That would be a squared plus ab plus ab plus b squared, which then simplifies to what we just had there. And then if I wanted to cube it, right, so that would basically mean take a plus b and multiply it by what we just got, right? So a squared plus 2ab. I can't read that. Let me fix it. 2ab plus b squared. So if I distribute the a through, I would have a cubed plus 2a squared b plus ab squared plus ba squared plus b times 2ab would be 2ab squared plus b cubed. And when I combine my like terms there, I would have 1a cubed, and then I have 3a squared b's, and I have 3ab squareds, and I have 1b cubed. Right, so obviously having to go through this long process to raise things to higher powers becomes extremely annoying. So we're looking for patterns here, right? So if you want to pause the video and kind of look at that, and there's a couple of different patterns we want to look at here. So what do you notice about the successive powers of a? Right, so when I'm raising this, so let's take a look at the cube one here. Right, when I start, a is cubed, and then a goes down to squared, and then I just have a to the first, and then technically it'd be a to the 0, so it's gone, right? So the powers of a are decreasing by 1. And then if I look at the powers of b, right, the powers of b, there is no b term, and then I get b to the first, and then b to the second, and then b to the third. So the powers of b are increasing by 1. So that's one thing to note. And then the other thing to notice is, what about the coefficients? So you may have wondered why I wrote it the way that I wrote it up here. But if you look, there's a 1. Those coefficients are 1 and 1. Those coefficients are 1, 2, 1. Those coefficients are 1, 3, 3, 1. And by golly, hopefully you can see that we have Pascal's triangle, right? They are from Pascal. All right. So if I didn't want to have to actually multiply out a plus b to the fourth, right, let's see if we can apply this pattern. So I know that it's going to start with a to the fourth. Then the next term, a is going to drop a power and be a cubed, but in comes the b, right? Then in the next one, a drops a power and b goes up a power. And then in the next one, a drops a power, b goes up a power. And then in the last one, the a would drop out entirely and b would go up a power. So that takes care of the a's and the b's. And then the last thing is to remember the coefficients from Pascal's triangle. So if I had 1, 3, 3, 1 from the last one, then the next one would be 1, 4, 6, 4, 1. Right? So there's going to be that fourth row of Pascal's. So 1, 4, 6, 4, 1. And that is a plus b to the fourth. How nifty is that? Right? So the cool thing is that if I wanted to jump to any row or any expansion, right, I could expand something like a plus b to the seventh. And all I would need to do is get to that seventh row of Pascal's. But to do that, there's actually a faster way than having to generate all the way to the seventh row. And that's what we saw yesterday. And so if I wanted to actually find a plus b to the seventh, then I could do a to the seventh. And then I'd have, again, a to the sixth. And b comes in. And then a goes down a power. B goes up a power. So I just follow that pattern. So I a lot of times like to go through and write all that out first. And then write this out. So A just keeps going down a power, B keeps going up. Okay. And then I like to come in with my Pascal numbers. And so technically what I could do is just write, well, this is 7 choose 0. And then this one's going to be 7 choose 1. And this one will be 7 choose 2, and 7 choose 3, 7 choose 4, 7 choose 5, 7 choose 6, and 7 choose 7, which is hard to fit in right there, but I will. 7 choose 7. So if I wanted to, then on my calculator, I can just come in and figure out what each of those are. So 7 choose 0 is 1. 7 choose 1 is 7. 7 choose 2 is, I think, 21. 7 choose 3 is 35. And then they just go right back down again. And there they are. So there I just expanded out a plus b to the seventh without ever having to actually multiply it out. So see, look at that. That's exciting. I mean, haven't you always wanted to be able to expand a plus b to the seventh that quickly? It's amazing. All right, let's take a look at a couple more examples here where it just gets a little more interesting because instead of just A's and B's, what if we used other letters and numbers? So if I want to raise this to the fifth, I'm going to use the exact same idea. Okay, so I'm going to be looking at t, and notice that this time it's minus 3. So what we could do is think of this as t plus negative 3 to the fifth. So I come in, and again, I like to personally go through and figure out the powers first. So I'd have t to the fifth. And then in my next one, the t comes down a power. In comes the negative 3. T comes down a power. Negative 3 is now squared. T comes down a power, so it's squared, which means the negative 3 is cubed. And then t comes down a power. Negative 3 goes up a power. And finally, negative 3 goes up a power, and the t drops out. One other thing to notice that if I go ahead and write the 1 in on these powers, notice that the power here is 5. If I add these two powers, 4 and 1, I get 5. 3 and 2 is 5. 2 and 3 is 5. 1 and 4 is 5. 5, right? So these will always add up to whatever the power is that you're raising it to. So that's just a nice little check to make sure you're putting the right thing in there. And then I just need my Pascal numbers. So I want to the fifth power. So that would be the fifth row of Pascal's triangle. So I could either use my combinations with my calculator, or fifth row is not too far. So I can just do it this way. Right, so it'd be 1, 5, 10, 10, 5, 1. So I know my coefficients then are 1, 5, 10, 10, 5, and 1. Now, the one thing on this is that this time we actually could go ahead and simplify because we have numbers. So we're going to have t to the fifth. And then when I multiply this out, notice that the negative 3 is to the first. So this is going to come out negative 15 t to the fourth. In the next one here, when I multiply this out, the negative 3 is going to get squared, making it positive 9. 9 times 10 is 90. And then I'd have t cubed. Then on the next one, because the negative 3 is raised to the third, right, that's going to come out negative. So I'm going to have 10 times negative 27. So that would be minus 270 t squared. And then I've got negative 3 to the fourth. So that's going to come out positive. So I'm going to have my 5 times 3 to the fourth is 81. Okay. So then if I multiply that out, I get 405 t. And then last but not least, when I raise negative 3 to the fifth, I get negative 243. So notice that when I get done here, because of the simplifying, I don't actually see, the Pascal numbers anymore because they've been multiplied in with other stuff, but that's my final answer. Now, another thing to point out here is notice that when it was subtraction in my final answer, notice that the signs just alternate. And that's always going to be the case because I'm going to raise them to an odd power, then an even power, odd power, even power, odd power. So because it's going to alternate, whenever I'm doing subtraction, I know I'm going to get that alternating pattern. Okay, so that's something to keep in mind. All right, let's do one more. And again, it's a two-step process, basically. You want to write it all out, then simplify it. Okay, so we're going to take, this time we've got a 2x and a minus y squared. So we're going to take 2x. It's going to get raised to the fourth. Then we're going to add that to, okay, now 2x gets cubed. In comes that negative y squared. Next term, 2x is now going to drop a power to the second. The negative y squared is going to go up a power, so it's now squared. Because over here it was to the first, now it's to the second. Then I'm going to have 2x. It drops a power, so it's to the first. The negative y squared is now cubed. And last but not least, the negative y squared is to the fourth. Now I need my Pascal numbers. So my Pascal numbers are 1, 4, 6, 4, 1. Because again, I want the fourth row of Pascal's triangle because I'm raising it to the fourth. So 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. There it is. Okay, and you've got the right row because there's 5 of them and I had 5 terms, so it should always work out. So then the last thing here is, again, just to simplify. Now, this is where I see a lot of times mistakes because notice that when I wrote the 2x, I wrote it in parentheses. That's because that whole thing is getting raised to the fourth, not just the x. So 2 to the fourth is 16x to the fourth. Okay? So you have to remember to raise the 2 to the fourth as well as the x. So then over here, when I go to do this next one, it might be helpful to just kind of go ahead and write out some stuff here. So we're going to have 4, 2 to the third is 8x cubed. Right? And then the negative is to the first, so it is going to come out negative y squared. So when I multiply the 4 times the 8 and times the negative, it's going to be a minus, right, 32. And then I've got x cubed y squared. Then when I go on to my next one, I'm just going to move this down so it's kind of our final answer. So when I go here to this next one, I've got the 6. The 2 gets squared, so that makes it a 4. But I also have x squared. And then here, when I square the negative, it becomes positive. And y squared squared, I multiply those powers, so I actually get y to the 4th. Okay, so I'm going to then get 24x squared y to the 4th. Then I go on to my next one here, and I've got 4 times 2 times, okay, well now again, that negative is going to an odd power, so it's going to come out negative. And a power to a power I multiply, so this is y to the 6th. Oops, I left my x out, didn't I? There we go. Okay, so I've got 4 times 2, but it's negative, right? So again, we're multiplying here, so this is going to be negative 8x y to the 6th. And then last but not least, that last one, the negative is going to get to the 4th, so it's going to end up positive. And then I'm going to have y to the 2nd to the 4th is y to the 8th. So again, when I get done, I don't actually see the Pascal numbers anymore. They've been distributed in, right? But the way it was generated used Pascals. So you got a worksheet, try a few of these, see what you come up with. And there's a couple of interesting questions that use sigma notation. So see what you think about those. You can work together and try to figure those out. And then we'll talk more about it on Thursday when I get back. All right.